Good day, students. This time we'll be having another lesson in Mathematics in the Modern World. This is your instructor, Mr. Japheth and Nabaira. But before we start our lesson, take note of these important features of the E-module. The first one is the checkpoint. If you will see this feature across the E-module, it conveys that you have to check your progress. It could be a practice exercise, a drill, or a thought-provoking question that will solicit your answer to better understand the topic discussed. Another important feature of the E-module is the key to correction. This feature in the E-module will give you immediate answers to the questions that are posted in the checkpoint section. No explanations will be provided to generate your own justification of the answers, hence enhancing your creativity and critical thinking abilities. So you have to take note of these two important features, the checkpoint and the key to correction. This will serve as an assessment to check if you really understand the lessons or not. Alright, so this time we'll be discussing E-module 2.1, Elementary Logic, Negation, Connectives, and Quantifiers. For the learning objectives, at the end of this lesson, the student should be able to determine whether the given sentences are statements, use connectives to form compound statements and quantifiers to state quantified statements correctly, and express statements in symbolic form and vice versa. As an overview, when we're talking about logic, the concept of statements are indispensable because these are needed to create arguments. In everyday English, we use so many different kinds of sentences. Some of these sentences are clearly true or false. Others are opinions, questions, and exclamations, such as help or fire. However, in logic, we are concerned solely with statements. And take note of this. Not all English sentences are statements. So we will discover more about statements, English sentences that are not statements, as we continue the discussion of this lesson. Let's start a discussion about statements. A statement is a declarative sentence that is either true or false, but not both true and false. Based on this definition of a statement, it has one truth value. It's either true or false, but it cannot be both true and at the same time false. That's very odd if a statement is both true and false. It's very confusing, right? It may not be necessary to determine whether a sentence is true to identify whether it is a statement. For instance, consider the sentence below. Iloilo is the most populated city in the country. You have some information to justify the truth and falsity of this statement? You may not know if the sentence is true, but you do know that the sentence is either true or it is false, and that it is not both true and false. Thus, even you do not know that the statement is true or false, you know that the sentence is a statement. Take note also that some sentences, such as commands, questions, and opinions, are not statements because they are not either true or false. The following sentences are not statements. For example, go to your room. That is a command. How can we say that this sentence is true or false? Because it is a command. That's why it is not a statement. If I start losing my memory, how will I know? Is it true or false? You cannot answer, right? Because it is a question. How can you say that a question is true or false? That's why the sentence is not a statement. Another one, Aklan is the most beautiful province in Region 6. This is an opinion, and we know that different people have different opinions. Maybe one opinion is true for a certain person, but it might not be true to another person. That's why the falsity and truth of a given opinion is subjective. Hence, this sentence is not a statement. Do you understand now that questions, opinions, and commands are not statements? Alright. In symbolic logic, we use lowercase letters such as P, Q, R, and S to represent statements. Here are some examples. Let P represent today is Tuesday. Let Q represent Jose Rizal wrote the poem The Last Farewell. And let R represent 5 plus 7 is equal to 12. Although 5 plus 7 is equal to 12 is not actually written in words, but we know that this is a statement. Why? Because 5 plus 7 is equal to 12 can either be true or false. Now, the letter P represents the first statement, Q for the second statement, and R for the third statement. Why do we need to learn this? Because later we'll be writing statements from words into symbolic form, and instead of using a long statement, we have to represent it with a letter, and those are the lowercase letters P, Q, R, and S. To continue, we have now a checkpoint. So you have to answer this if you really learn how to identify whether a given sentence is a statement or not. Here are the sentences. Welcome to Aklan. 3 plus 1 is less than 5. Find a number that is less than 10. Duterte is the oldest president of the Philippines. Are you hungry? So, try to contemplate and think which of the following sentences are statements and which are not. You can pause this video for 2 minutes or 3 minutes for you to think critically and analyze carefully. Did you get it? Alright. I guess you have now your answers. Here is now your key to correction. The first sentence is not a statement. Second, it is a statement because it's either true or false. Third, it's not because it's a command. The fourth sentence is a statement. And the fifth sentence is not a statement because it's a question. Alright, so I think you don't have any question about identifying whether the given sentence is a statement or not. Let's continue the discussion. Connectives and compound statements. If you're going to observe the picture, it has if-then. And later you will discover that if-then is one of the connectives used to form compound statements. Connecting simple statements with words and phrases such as and, or, if-then, and if and only if creates a compound statement. What is the difference between simple statements and compound statements? A simple statement is a statement that conveys a single idea, but a compound statement is a statement that conveys two or more ideas. Now, if you are going to combine two or more simple statements, then you will probably get a compound statement. Words and phrases like those that are stated above are called connectives. So what are our connectives? And, or, if-then, and if and only if. Because they join simple statements to form compound statement. For instance, I will attend the meeting or I will go to school. It is a compound statement. Why? It is composed of two simple statements. And what are those? I will attend the meeting. That's the first simple statement. And the next one is, I will go to school. What connective was used? The word or is a connective for the two simple statements. See the difference between a compound statement and a simple statement? To continue, let's start with the negation. And here is the symbol for negation, the tilde symbol. Now, consider the statement today is Friday. The most common way to negate this statement is to introduce the word not into the sentence. The negation, therefore, of the sentence today is Friday is today is not Friday. In symbolic logic, the tilde symbol, the one that was presented, is used to denote the negation of a statement. For example, if P is the statement, the negation is tilde P. This is read as not P. And take note of this, if a statement P is true, of course, if you're going to negate it, not P is false. And at the same time, if a given statement P is false, of course, the negation is true. Did you get it? Another thing to take note for negation. The negation of a given statement is the original statement. That means if you have a statement, then you negate it. If you're going to negate it again, that will return to the original statement. Thus, the negation of P can be replaced by P, which is the original statement. For example, let the statement P represent today is Friday. Then the negation of P or not P is today is not Friday. But if you're going to negate it again, now the negation of P is equal to the original statement P. If the given negation not P is negated again, that will give you today is Friday. Because the negation of today is not Friday is today is Friday. See the logic? That is very easy, right? So to check your understanding, we have a checkpoint. Now, give the negation of the following statements and express them in symbolic form. That is with the use of the tilde symbol. The first statement, let P represent blue is the color of CTE. And the second statement, not Q represent 13 is not a prime number. So you can pause the video again for 2 minutes, I think, or even 1 minute. It's very easy. And then you can check your answer afterwards. Alright? I guess you have now your answers. Here are the key to your corrections. For the first statement, the negation is not P, and that is blue is not the color of CTE. That's very easy because you just have to introduce the word not. For number 2, 13 is not a prime number. Now the negation of not Q is of course Q. And that is 13 is a prime number. You just have to omit not. Did you get it? Alright. We'll proceed with conjunction. And what is the symbol for conjunction? This is the symbol, the inverted letter V. Now, if P and Q represent two simple statements, then the compound statement P and Q is symbolized by P, the inverted letter V, and Q. And that is read as P and Q. The compound statement formed by connecting statements with the word and is called a conjunction. In English, we do have our conjunctions, right? And we know that the word and is one of the conjunctions in English. It's very easy to remember this concept. For example, let P and Q represent the following simple statements. P, it is after 5 p.m. Q, they are working. Now, try to write P and Q into words. That is, P and Q, it is after 5 p.m. and they are working. It's very easy because you just have to introduce the word and. What about vice versa? Try to write this statement into symbolic form. It is after 5 p.m. and they are not working. That is, the first statement is P, and then the word and will be represented by the inverted letter V symbol. And since the last statement is the negation of Q, then you will use tilde Q or not Q. Basically, you will have this P and not Q. Did you get it? Alright. To practice your skills in forming conjunctions, answer the following questions. Let P and Q represent these two simple statements. We have the same given. It is after 5 p.m. they are working. Now, express this statement into symbolic form. It is not after 5 p.m. and they are working. It's very easy. And second statement, express the symbolic form into words, not P and not Q. I guess you can answer this in just 2 minutes. So you can pause the video again and try to think of the possible conjunction that you can form based on the question. Did you get it? Alright, shall we check your answer? Here is now your key to correction. For the first question, since you have negated the first statement, so that will become not P and Q, because the last statement is still the original statement Q. And of course, for number 2, not P and not Q, you just have to negate the first statement and the second statement and then introduce the word and between them. That is, it is not after 5 p.m. and they are not working. It's very easy, right? We will proceed with disjunction. So what's new with disjunction? What's the difference between conjunction and disjunction? It utilizes the symbol, the inverted symbol for conjunction, and that is the letter V. Now, when the connective or appears in a compound statement, that means an inclusive or. How are we going to understand an inclusive or? If P and Q represent two simple statements, then the compound statement P or Q means P or Q or both. The compound statement formed by connecting statements with the word or is called a disjunction. See the difference between conjunction and disjunction? In conjunction, we're using the word and. In disjunction, we're using the word or. Now, the symbol for or is like a letter V. Thus, we can symbolize the compound statement P or Q as P and introduce the symbol V, then Q. So that will become P or Q. Let's apply it to some example. Let P and Q represent the following statements. The bill receives majority approval for statement P and the bill becomes a law for statement Q. Now, try to write P or Q into words. This is very easy because you just have to copy the first statement P, introduce the connective or, and then copy the statement Q. This will become the bill receives majority approval or the bill becomes a law. Did you get it? What about the other one? Try to write this statement into symbolic form. The bill receives majority approval or the bill does not become a law. If you're going to observe this compound statement, the first simple statement, the bill receives majority approval, is just represented by letter P. And then you will introduce the symbol for or, but take note of the second simple statement. The bill does not become a law. So that is the negation of the statement Q. So you're going to write not Q. Most probably, this will look like this. P, the symbol for or, which is letter V, and not Q. Did you get it? Okay, this time, it's now your turn. Let P and Q represent these simple statements. You graduate for P, and for Q, you satisfy the course requirement. So, express this statement into symbolic form. You graduate or you satisfy the course requirement. And the other one, express the symbolic form into words. Q or not P. Alright. Again, you can pause the video and then try to think of the answer for these two questions. And then play it again for you to view the correct answers. Is that clear? I guess you have now your answers. For the first question, that is P or Q. It's just very simple. You just have to copy the first statement P, introduce or, and then since there's no alteration in the second statement, you just have to write Q. And that's the answer. Next, Q or not P, that means you have to write first the statement Q, you satisfy the course requirement, introduce or, and negate the first statement, or you do not graduate. See to it that when you're going to write a compound statement, it must be correct also grammatically. Alright? Because mathematics is also a language. Now we'll be moving on to the next compound statement, and that is a conditional. What's the symbol? An arrow. Consider the statement: if a person is a poet, then that person is a writer. Now what I am trying to emphasize here is the connective if, then. The form of this statement is if P, then Q. The compound statement if P then Q is symbolized by P, arrow, then Q. Now if you're going to view the example, our P there is a person is a poet. Our Q there is a person is a writer. Now if you're going to connect it with if then, you can write it in symbol P, arrow, Q, and that is read as if P then Q. The compound statement formed by connecting statements with if-then is called a conditional statement. And the symbol if-then is symbolized by an arrow. Take note of this. In a conditional statement, the statement before the arrow connective is called an antecedent. And the statement after the arrow connective is called the consequent. Well, that means the if statement is called an antecedent, and the then statement is called a consequent. Alright? Now, let's have some example. Let P and Q represent the following simple statements. P, a person is a father. Q, a person is a male. Try to write the symbolic statement P, arrow Q into words, or if P, then Q. It's very easy. If a person is a father, then that person is a male. Now let's try the other one. Try to write this statement into symbolic form. If a person is a male, then that person is a father. It's just a reverse of the given statement, right? So in symbol, you just have to write first the letter Q, then an arrow, and then the letter P that represents the first statement. Is that clear? Alright. We have now another exercise for you to practice your skills in forming if-then statements. Let P and Q represent these simple statements. The same with our given. P, a person is a father. Q, a person is a male. Now, express the statement into symbolic form. If a person is a male, then that person is not a father. And the next one is express the symbolic form into words. Not Q, then the arrow, and then not P, which is read as if not Q, then not P. Again, you can pause this video for 2 to 3 minutes and answer it with your own so that you will develop the skill in forming if-then statements. Then you can play again the video to view the correct answers. I think you have now your answers. So here's now your key to correction. For the first question, the answer is Q, arrow, not P. Why? Because the first statement is if a person is a male, and that is the second statement, Q. Then you're going to write an arrow. That person is not a father. That means the negation of the statement P. So you have to write not P. For the second question, not Q, arrow, not P, or if not Q, then not P. That means you have to negate the second statement. If a person is not a male, then the negation of the first statement, that person is not a father. See, we're applying two connectives here, the if-then and the not, or the negation. Do you understand it now? Alright, we'll be moving on to biconditional. If we have a conditional, then we also have a biconditional. The symbol is an arrow with heads in both ends. Now, consider the statement. A person is an unmarried male if and only if that person is a bachelor, which is true. If P and Q represent two simple statements, then the compound statement P if and only if Q is symbolized by P if and only if Q. Or P, an arrow with heads in both ends, and Q. Why we have an arrow with heads in both ends? Because a biconditional represents a statement that is if P then Q, and at the same time if Q then P. Since we have two conditionals in both directions, that's why we have an arrow with both heads in both ends. Alright? The compound statement formed by connecting statements with if and only if is called a biconditional. And the symbol for if and only if is, as what I have mentioned, an arrow with two heads in both ends. And the phrase if and only if can be abbreviated as IFF. For certain examples, let P and Q represent these simple statements. P, a person is an unmarried male. Q, a person is a bachelor. Now, if you're going to write Q, if and only if P into words, how are you going to do that? This time, you're not using if then anymore. Just write the second statement, a person is a bachelor, introduce if and only if, then write the first statement, a person is an unmarried male. So here it is. A person is a bachelor if and only if that person is an unmarried male. What about this? Try to write this statement into symbolic form. A person is not an unmarried male if and only if that person is a bachelor. It's actually the same but with some alteration because the first statement is the negation of the statement P. So you just have to introduce not P. Then the symbol for if and only if is the arrow with both heads in both ends. And you write the second statement, the symbol is Q. So basically that will become not P if and only if Q. Okay? It's now your turn to check your progress. Let P and Q represent these simple statements. She is wealthy. Q, she is happy. Now express this statement into symbolic form. She is happy if and only if she is wealthy. And the second one, express the symbolic form into words. Not Q, if and only if, not P. Again, you can pause this video for 2 minutes or 3 minutes for you to analyze carefully. Is that clear? Alright, I think you have now your answers. Now for the first question, she is happy. You just have to copy the second statement, symbol Q, introduce the symbol for if and only if, and then copy the symbol for the first statement, P. So this is very easy. And for the second question, not Q, that means you just have to negate the second statement, then if and only if, and then negate the first statement. So in words, she is not happy if and only if she is not wealthy. Do you understand it now? Alright. We will proceed with the next topic, quantified statements. What are quantifiers? These are expressions or phrases that indicate the number of objects that a statement pertains to. Of course, this pertains to quantity. That's why the number of objects. Now, in a statement, the word some and the phrases there exist and at least one are called existential quantifiers. Why existential? Because they are used as prefixes to assert the existence of something. When we say some students of ASU are taking BS Ed course, then that means there exists a student in ASU that take BS Ed course because that is an existential quantifier. Now, in a statement also, the words none, no, all, and every are called universal quantifiers. Why? Because these terms are generic. That means when you use that term, that is true to all the elements that belong to the given set. For example, all ASU students are beautiful. So that means there's no ASU student that is not beautiful, right? I think you will agree with me if I'm going to write that statement here. And here is a table for a summary. For example, if we have a statement all A are B, now an equivalent way to express this statement is there are no A that are not B because all A are B. Now for example, all poets are writers. Equivalently, you can express it as there are no poets that are not writers. Do they have the same meaning? It's a resounding yes, because all poets are writers. That means there are no poets that are not writers. It's very easy to express a certain statement which has an equivalent meaning with the given statement, right? What about if the statement is some A are B? That means there exists at least one A that is a B. Some is an existential quantifier. For example, some people are bigots. That means at least one person is a bigot because the word some means there exists at least one. Did you get it? Now, what if the statement is no A are B? That means all A are not B. Say for example, no math books have pictures. That means all math books do not have pictures. See, they mean the same thing. They were just expressed in a different manner. Lastly, some A are not B. That means not all A are B. For example, some students do not work hard. I really agree with this because I can see some students do not work hard. Equivalently, you can say not all students work hard. Logically, they mean the same thing, right? So this part of the EMODULE teaches you to express quantified statements in a different way, but with the same meaning with the original statement. Okay, let's try if you learn the lesson in expressing a given quantified statement to another quantified statement with equivalent meaning. Here's the direction. Express these quantified statements in an equivalent way, that is, in a way that have exactly the same meaning to the given statement. So here are the statements. All whales are mammals. Some thieves are not criminals. Some BSED students are science majors. Okay, so I guess this is a little bit challenging. So you can pause this video for at most 3 minutes or 5 minutes for you to analyze carefully. Alright, so you can pause the video and play it again to check your answers. Alright, so I think you have now your answers. In the first statement, all whales are mammals, you can state this as there are no whales that are not mammals. They just mean the same thing. In the second statement, some thieves are not criminals. You can restate this as not all thieves are criminals. Did you get it? Lastly, some BSED students are science majors. So you can restate this as at least one BSED student is a science major because this is an existential quantifier. Did you get it? Alright, we will proceed. Now take note of this. The rules of logic will help you to evaluate the vast array of claims facing you as a consumer, a citizen, a student, and a human being. Understanding logic will also allow you to construct better and more convincing arguments of your own, thereby becoming a more effective advocate for your beliefs. Restating a statement to another with equivalently the same meaning will also help you internalize the fact that no matter how the statement is expressed, the meaning is still similar. This will guide you to better scrutinize ideas before accepting them. I guess this lesson in eModule 2.1 have helped you a lot in restating statements in equivalent manner and informing different compound statements using different connectives. Okay, So that ends our EMODULE 2.1. And if you want to read more about this topic, here are your references. We also have the photo credits to the icons that I've utilized in this EMODULE. Have a great day, everyone, and God bless.